All right, CNT120, we are working on Chapter 3. We talked in the last podcast about MAC addresses. Now we're going to move into IP addresses. We're probably going to break this into multiple pieces, but we'll get started. We're going to talk about IPv4 addresses, then we'll work our way into IPv6 addresses. So, reminder, network layer. Layer 3 of the OSI, we have our IP address. That's the addressing we encounter at this layer. Remembering, this is assigned to every interface, every node connected to the network, and this can be used to find any computer in the world, so to speak, as long as it's connected to the public internet, if you will. And mainly IP addresses are used for routing. As we said before, I'll remind you here in another second why I'm saying that. And remember, there's also multiple names for IP addresses. Logical address, because it's something that can be changed and there is some logic to it. Software, because it is an address that can be changed. Layer 3, because the layer 3 of the OSI model. And network layer, because the network layer. Okay, network layer of the OSI model. Remember, there is IP version 4 and IP version 6 addresses. IP version 4 we're going to start with first, 32 bits, written as 4 decimal numbers, 92.106. Okay, that's typically your IP version 4 address, but it would be 32 bits if you wrote it out in binary. Your IP version 6 address is 128 bits if you write it out in binary, but it's typically represented not in a decimal number, but it's typically represented in a hexadecimal number, like so. And here would be a full IP version 6 address, and that is full hexadecimal because you see your letters and your numbers in there. All right, let's talk IP address in general, then we're going to work on IP version 4. Remember, our networks typically use 2 addresses. Now, we're talking about multiple in this chapter, I know, but the big ones we talk about are the logical address or IP address and the physical address or the MAC address. And remember the example I used before, the logical address or the IP address is used by devices like routers to get the data to the correct network, and its job is done. This would be like mailing a letter, and the letter getting to the correct city, Mechanicsburg, correct street, Main Street, and the correct house, 123 Main Street. And that's, in comparison to 123 Main Street in Harrisburg, or Hershey, or York, or Gettysburg, or Lancaster. I'm getting it to the correct house. That's the job of the IP address, or in this case, I should say the job of the address on my letter is to get it to the correct house, and the job of the IP address is to get it to the correct network. Example, the York campus network of hack versus the Gettysburg campus network of hack. We want to make sure it gets to the York campus. That's the right campus for this particular data packet. Meanwhile, once it gets in the door of that campus, the MAC address gets used by the switches to get it to the correct node, the correct PC at the York campus. And this would be like, in our letter example, getting it to the correct person in my house. So the letter got to 123 Main Street, Mechanicsburg, PA. Once it's there, now we read the name on it and realize it's for Doug or his wife. We now read the name on there to get it to the correct person. And again, this is like in my network example, the IP address is getting it to the York campus hack versus Gettysburg. And once it's there, the switches read the MAC address and get it to the correct PC at York campus. My PC as opposed to my neighbor's PC. Okay, that's what both of these main addresses are being used for. The MAC addresses are getting used by the switches to get to the right node. The IP addresses are getting used by the routers to get to the right campus. This campus as opposed to this campus. Okay, so keep that kind of in your brain to kind of keep those two sorted out. Because a lot of people get lost. They don't realize, or they don't connect the dots that we actually need both of the addresses. They think one or the other. No, we actually do need both. They then remind us about static addresses and dynamic addresses. Static addresses are manually assigned by your network admin, and it's done for static type devices, things like printers and servers that I need to consistently hit all the time. And we don't want that address changing. We don't want that moving around the network, so to speak. We want it to always have the same number so we can print to it or get files from it. That's important. So we'll assign a static IP address to it so I can always find it, I can always get it, I can always send files to it. The only problem is if we left all users do this to all their computers, you might have duplicates and might have problems. This is usually only done for specific static devices. And to do a static IP address, if I look at my IP address settings, I literally go to my IP address setting change and say use the following IP, and I manually plug in all the settings that we need to use. The IP subnet mask and default gateway. That's what I would do. and it looks something like this. I'm going to pull up my IP address setting changes on my Windows computer here. I'll go to my Network and Sharing Center. I'll find my NIC that I'm using. I'll go to the properties for it, and then I'm going to open the TCP/IP version 4. That's what I'm altering. Open the properties. I'll see now it's obtain IP address automatically. If I wanted to put a static, I would click that button right there and start filling in the information. 192, 168, and so forth. Okay, that's all I need to do to assign a static IP. But I do need to understand my number as well to do that, or I'm going to cause a conflict or a problem that things aren't going to work. All right, again, and that's usually done for things like printers, servers, those kind of things that I need to remain stationary in my network. Meanwhile, I have dynamic IP addresses. Dynamic IP addresses these are addresses assigned from a router running a DHCP server or an actual DHCP server. A DHCP server is designed to hand out IP addresses for computers to borrow them for a while. Allows you to borrow that IP address for a day or a couple days. And the idea being here, a device like somebody's laptop or desktop, you can literally bring it in, plug it in the network, and it's going to get the correct IP and be connected on the network and usable. And that gets rid of the human error part of users in your network or employees in the network not plugging the correct number and not having your computer on the network and work. This allows for the server to hand out the correct number to them. They can literally just turn their computer on, get the IP they need, and have it work. So this oftentimes gets used for a lot of the regular everyday devices in your network. And to do that, I go to my network settings and just do the obtain IP address automatically, which again, if I go to my network settings, I'll go in here to my network settings again, go to network and sharing, go into Ethernet, pull up my properties, IP4, properties, and you'll see right now I'm set for obtain IP address automatically. It is getting an IP address from the DHCP server at the college. In this case, I'm connected to one of the computers in our lab room. So if I take 2 seconds, let me show you. I'll look at my IP settings, do an IP config. I'm going to do an IP config /all. That's going to allow me to show you Ethernet 3. Here's Ethernet 3 right here. There's the NIC I'm using. Here is my IP version 4 address. There he is. And if I look a little closer, I'll see a lease obtained, lease expires. This IP address was leased from the DHCP server on this date and will expire on this date. That tells you this is set for DHCP and it's getting the IP address from the DHCP server. It's set for dynamic addressing. Most client devices or client computers are set for this, and it minimizes the number of IP addressing problems or conflicts that you'd have in a network. Also a reminder, if a computer is set to be using DHCP, again, like I showed you, getting IP address from the DHCP server, and it cannot reach one. It cannot get it. It's unable to find it. It can't get it. The server's off. There's a connection problem. It'll try, and after it tries a couple times, it says, okay, I can't find one, and it's actually going to self-assign an PIPA address, automatically private IP address. A PIPA address. It's going to assign itself an IP address in the 169.254 range. So if you ever look at an IP address on a machine and you see 169.254, you know, again, I'm going to go here to my IP settings. I think you're catching on this one. Ethernet 3, properties, go to TCP IP version 4, properties. When I see it 169.254, I know my computer is set for obtain IP address automatically, and for some reason it can't talk to that DHCP server and get an IP address. There's a connection issue. There's the server's down, the server's overwhelmed, switch port is off. Something is not right that I can't get to the DHCP server and get an IP address. So if I see a 169.254, that's usually a clue of that is the particular problem. You normally do not ever want to see this address. So I always tell people when you see that, it's kind of like a red flare or rockets going off, or a bottle rocket or something going off. It should be a warning that something's not right. I need to dig and find my IP address problem that I have or connection problem that I have. That is a worthwhile one to recognize, 169.254. Here, when I start looking at IP addressing, the book actually takes a second and says, okay, let's understand all these numbers, which is worthwhile to do. The first line I see when I was doing all those IP address changes is the IP address, 169, or in this case, 192.168.2.2. You'll notice it is 4 octets. It's 4 numbers, 4 decimal numbers that are from 0 to 255. That is my IP address. This is identifying this particular node on the network. So if I go back here, when I looked at my IP address, there it is. That's identifying my node on the network. The next number I have here is my subnet mask. This normally goes along with the IP. The subnet mask is used to tell you what portion of the IP address is network, what portion is subnet, if there is any. You notice I say it's in parentheses there, if there is any, and then what portion of the address is host. So as I take a look at this one real quick, this guy here says 255.255.255.0. That tells me these first 3 pieces are network. This last little piece is host. So this right here is identifying the host. The rest is identifying the network portion of the address. Just realize for now, those 2 numbers normally get used together. And I joke that the subnet mask is almost like a decoder ring to tell you what's going on with the IP address. They need to go together. Okay? So just kind of realize that for now. The next number, default gateway, 192.168.2.1, this is the address of a device like a router or a gateway or a firewall that's going to get me access outside of my network to either another network or the internet, if you will. So this is my default gateway. This is my gateway device. This is my router or default gateway or firewall that is getting me access outside of my network to either another part of my network or the internet. That is the address there. Okay, that is the address there. That is very important. I'm not going to get pretty much anywhere unless I have that number correct. Last but not least, the number I have down here, my DNS server, this is the address of the DNS server. This is the address of the server, the device that is going to be able to resolve a name into an IP address. So when I type in my URL bar, imsa.com, that's a racing website I like to go to, imsa.com, that gets sent to a server, and the server looks up and replies with, here's the IP address you're looking for, and then I go talk to that IP address. The domain names are for us humans. The domain names for us humans, because we have a hard time remembering IP addresses because it's all just numbers. So DNS servers are there to resolve names into numbers so we can talk to numbers on the internet. So this is the address of the DNS server that I'm going to talk to resolve my URLs, my website names, my domain names into IP addresses. And in this particular case, 8888 is the IP address of the Google DNS server, just as a little side note. And then here, again, I've actually done this with you already, but remind you again, if I do an IP config on my Windows machine, I can see the IP address. Here is my Windows machine, so I'll do an IP config here. IP config, I can actually see my IP address. There he is, right there. Ethernet 3, 172.23.164.77, followed with the subnet mask right below it, and the default gateway right below it. All 3 pieces of information that I normally need are right there. If I wanted to see the DNS, I would need to do all behind it, and it'll actually show me the address of the DNS server as well. So here is, in this case, there's my MAC address. There's my IP, subnet mask, default gateway. Down here is the address of the DNS servers. Okay? So there's how I see it on a Windows machine. On a Linux or Apple machine, I'm going to use my command prompt here, my terminal prompt. I'll use ifconfig. ifconfig will show me IP address, subnet mask, etc. Okay, there's my IP address, subnet mask for my Linux machine, 172.23.164.115. And that's how I do it on a Mac or a Linux machine. Okay? I'm going to pause there. We'll come back and continue on with IP addresses.